Hello students, let's begin our third chapter, Reactivity series and Electrochemistry. In this chapter we will learn the difference in reactivity of metals with water, air and acids, reactivity series and displacement reactions, galvanic cells and electrochemical reactions, electroplating and its practical utilities. Let's begin. Observe certain instances and a few sources of electricity shown in the picture. We use different kinds of batteries to work electronic equipments. Here, chemical energy is converted into electrical energy and vice versa. Haven't you seen the rusting of iron and the formation of verdigris on copper? Are all metals like this? Some metals engage in chemical reactions vigorously, certain others react sluggishly in the same reaction. Let's find out the difference in reactivity of metals. Reactions of metals with water. Let's find out the reactivity of sodium, magnesium and copper with cold water first. Take 3 test tubes having same quantity of water. Take pieces of sodium, magnesium and copper of same size and drop each one to each test tube. Observe the reactions. Only sodium reacts with the cold water. In these test tubes, which metal reacts vigorously? Sodium. Which gas is formed as a result of this reaction? Hydrogen. Now, what is the chemical equation? Na plus H2O gives NaOH plus H2. Now, heat the other both test tubes simultaneously. What do you observe? Only magnesium reacts with the hot water. From this experiment, we can conclude that the reactivity of metals with water follows the order sodium greater than magnesium greater than copper. The reactivity of sodium is greater than magnesium, but copper doesn't react with the water. Reactions of metals with air. The freshly cut surfaces of metals will have a shiny appearance. This property is known as metallic luster. Now observe the cutting of sodium using a knife. Don't you see a shiny appearance? And also you can see that it fades after some time. Why is it so? This is due to the conversion of sodium into its compounds by reacting with oxygen, moisture and carbon dioxide in the atmosphere. A fresh magnesium ribbon loses its luster when kept exposed in the air for some days. Similarly, the luster of aluminium vessel diminishes as the time passes by. In the case of copper vessels, it takes months for the loss of luster by the formation of verdigris. Does the shining of gold fade even after a long time? Doesn't this indicate that the metal reacts with air at different rates? Now tell me, which metal among magnesium, copper, gold, sodium and aluminium loses its luster at a faster rate? Sodium, right? Now can you list the above metals in the decreasing order of their reactivity with air? It follows the order sodium greater than magnesium greater than aluminium greater than gold greater than copper. Let's examine the reactions of iron, magnesium, copper, lead, zinc with dilute hydrochloric acid. Take equal volume of dilute HCl in 5 test tubes. Immerse metallic rods of iron, copper, zinc, magnesium and lead respectively in these test tubes. Observe the reactions taking place in each test tubes. You can see more bubbles are formed in the test tube with magnesium than that of zinc. Similarly, the number of bubbles that comes out are more in test tube with zinc than that of iron. Only few bubbles come out in test tube with lead and no reaction takes place in test tube with copper. Hence, the order of reactivity of metals with dilute hydrochloric acid can be written as magnesium greater zinc greater iron greater lead greater copper. From the above experiments, it can be concluded that the reactivity of different metals with water, air, and dilute hydrochloric acid are not the same. If the metals are arranged in the decreasing order of their reactivity, a series is obtained called reactivity series. The order of reactivity of some metals are given. Note, the nonmetal hydrogen is also included in this series. This reactivity series is used to compare the reactivity of metals. The metals above hydrogen in reactivity series can displace hydrogen from dilute acids, whereas those below hydrogen cannot. So students, let's conclude today's topic. We learnt about the reactions of different metals with water, air and acids. And we found the reactivity of different metals are different in each cases. The elements can be arranged in the decreasing order of their reactivity in a series called a reactivity series. Using this series, we can compare the reactivity of different metals. Thank you.